how did the United States become the undisputed ruler of the skies? A century ago, its aircraft were fragile wooden frames, slow, vulnerable, and barely capable of carrying weapons. Today, they are nearly invisible machines capable of striking targets before the enemy even knows they exist. Somewhere between those two extremes lies one of the most important transformations in modern military history. This is not just a story about faster jets or more powerful weapons. It is a story about how technology, strategy, and ambition combined to create a level of air dominance that few nations can even challenge. From the muddy battlefields of World War I to the high-speed duels of the Cold War, and finally, to the stealth-driven warfare of today. This is the evolution of American air power and how it came to dominate the skies. The story of American military aviation is not merely a tale of machines, but a reflection of technological ambition, strategic necessity, and the relentless pursuit of air superiority. Over the past century, the United States has transformed its air power from rudimentary wooden aircraft into some of the most sophisticated flying systems ever engineered. To understand how the United States came to dominate the skies, one must trace this evolution across distinct historical phases, each shaped by war innovation and shifting doctrines of combat. In the earliest years of the 20th century, aviation itself was still an experimental endeavor. Aircraft were fragile, slow, and limited in both range and payload. During World War I, the United States entered the conflict with relatively underdeveloped air capabilities compared to European powers. American aircraft of this period were primarily used for reconnaissance, serving as aerial observers rather than offensive weapons. Pilots flew open cockpit biplanes, constructed from wood and fabric, navigating with minimal instrumentation and often relying on visual landmarks. Combat, when it occurred, was improvised with pilots using handheld firearms before machine guns were eventually synchronized with propellers. This early phase established a crucial principle that would shape future development. Control of the air provides a decisive advantage on the ground. Even in its infancy, aviation demonstrated its potential to extend vision beyond the battlefield and disrupt enemy movements. However, it was not until the interwar period that the United States began to systematically invest in air power as a strategic asset. Between World War I and World War II, American engineers and military planners focused on improving aircraft performance, reliability, and range. Advances in aerodynamics, engine design, and materials gradually replaced fragile structures with more durable all-metal airframes. This period also saw the emergence of strategic bombing theory, which argued that wars could be won by targeting an enemy's industrial and logistical infrastructure from the air. While still debated at the time, this concept would soon be tested on an unprecedented scale. World War II marked a turning point not only for American aviation, but for modern warfare as a whole. The United States rapidly expanded its industrial capacity, producing tens of thousands of aircraft that ranged from agile fighters to long-range bombers. This was the era in which air power became central to military strategy. Aircraft were no longer auxiliary tools. They were decisive instruments capable of shaping the outcome of entire campaigns. Fighter aircraft of this period achieved remarkable improvements in speed, maneuverability, and firepower. Long-range escort fighters enabled bombers to penetrate deep into enemy territory, while heavy bombers carried out sustained campaigns against strategic targets. The concept of combined arms warfare increasingly relied on air superiority as ground forces depended on air cover and support to advance effectively. Technological advancements such as radar also began to influence air combat, providing early warning capabilities and enhancing coordination. Equally important was the scale at which the United States operated. The ability to mass-produce high-performance aircraft gave the country a significant advantage. Production lines became as critical to victory as the aircraft themselves, ensuring that losses could be replaced and operations sustained over long periods. This industrial strength, combined with evolving tactics, allowed the United States to project power across both the European and Pacific theaters. However, even as World War II demonstrated the effectiveness of propeller-driven aircraft, it also revealed their limitations. Engineers had already begun experimenting with jet propulsion, a technology that promised dramatically higher speeds and altitudes. By the end of the war, it was clear that the future of aviation would be defined by this new form of propulsion. The transition from propeller-driven aircraft to jet-powered fighters in the post-war period represented one of the most significant technological shifts in military history. Jet engines enabled aircraft to exceed the speed of sound, fundamentally changing the dynamics of air combat. Engagements that once unfolded over minutes could now occur in seconds, demanding faster decision-making and more advanced targeting systems. This transformation coincided with the onset of the Cold War, a period defined by intense competition between global superpowers. During the early Cold War years, the United States prioritized the development of high-speed interceptors and versatile fighter aircraft capable of countering potential threats. The Korean War served as the first major test of jet combat, where American pilots engaged in high-speed dogfights that differed dramatically from those of World War II. Lessons learned from these encounters informed subsequent designs leading to aircraft that balanced speed range and firepower with increasing sophistication. As the Cold War progressed, the role of electronics became more prominent. Radar systems evolved from basic detection tools into integral components of targeting and navigation. Missiles began to supplement and in some cases replace traditional gun armament, allowing pilots to engage enemies at greater distances. Aircraft were no longer judged solely by their physical performance, but also by their ability to process and utilize information. This shift marked the beginning of a broader transformation in military aviation, the integration of technology as a force multiplier. Aircraft were becoming platforms for complex systems, combining propulsion, avionics, and weaponry into a unified whole. The emphasis was no longer just on flying faster or higher, but on achieving superior situational awareness and operational flexibility. By the latter half of the 20th century, American military aviation had entered a new phase characterized by multi-role capabilities. Instead of designing aircraft for narrowly defined missions, engineers sought to create platforms that could perform a variety of tasks, including air superiority, ground attack, and reconnaissance. This approach increased efficiency and adaptability, allowing the military to respond to a wide range of scenarios with fewer specialized aircraft. At the same time, pilot training and doctrine evolved to match these technological advancements. Air combat tactics became more sophisticated, incorporating coordinated maneuvers, electronic warfare, and beyond visual range engagements. The human element remained critical, but it was increasingly supported by advanced systems that extended the pilot's capabilities. As we move toward the end of the 20th century, it becomes evident that the United States had established a clear trajectory, continuous innovation driven by both necessity and ambition. Each generation of aircraft built upon the lessons of the previous one, resulting in a steady progression toward greater performance versatility and technological integration. This foundation set the stage for the next major leap in aviation, the emergence of stealth technology and fifth-generation fighters, which would redefine what it means to control the skies. But to fully appreciate that transformation, we must first examine how the principles developed during the Cold War matured into the advanced aircraft systems that dominate modern warfare today. As the 20th century drew to a close, American military aviation entered what can only be described as a transformative era, one defined not merely by faster or more agile aircraft, but by a fundamental rethinking of how air power is conceived, deployed, and sustained. The lessons of the Cold War, combined with rapid advances in computing materials, science, and sensor technology, gave rise to a new generation of aircraft that would prioritize information dominance as much as physical performance. This shift ultimately culminated in the development of fifth-generation fighters, where stealth data integration and network-centric warfare became the defining characteristics of air superiority. At the forefront of this evolution stands the F-22 Raptor, widely regarded as the most capable air superiority fighter ever built. Conceived during the final years of the Cold War and entering service in the early 2000s, the F-22 was designed with a singular objective to ensure absolute dominance in air-to-air combat against any conceivable adversary. What distinguishes the aircraft is not just its speed or maneuverability, although both are exceptional, but its ability to operate undetected. Through a combination of radar-absorbing materials, carefully engineered airframe geometry, and internal weapon bays, the F-22 minimizes its radar signature to a degree that fundamentally alters the engagement equation. In practical terms, this means that the aircraft can often detect, track, and engage enemy targets long before it is itself detected. When combined with its capability for sustained supersonic flight without afterburner known as supercruise, the F-22 achieves a level of tactical flexibility that remains unmatched. It is not simply a fighter, it is a system designed to control the battlespace, dictating when and how engagements occur. Despite its unparalleled capabilities, however, the F-22 program was limited in scale and the aircraft was never exported, reflecting both its cost and the sensitivity of its technology. Complementing the F-22 is the F-35 Lightning II, a platform that represents a different but equally Gurut-Bjornen philosophy. Whereas the F-22 was engineered primarily for air superiority, the F-35 was designed as a multi-role aircraft capable of performing a wide spectrum of missions, including ground attack, reconnaissance, and electronic warfare. It is in many ways the embodiment of modern joint operations built to integrate seamlessly with other assets across air, land, sea, and cyber domains. The defining strength of the F-35 lies in its advanced sensor fusion capabilities. Rather than presenting pilots with disparate streams of information, the aircraft systems synthesize data from multiple sensors into a coherent and intuitive picture of the battlefield. This allows pilots to make faster, more informed decisions, effectively extending their awareness beyond the limits of traditional line-of-sight engagement. In this sense, the F-35 functions as both a combat aircraft and an intelligence node capable of sharing real-time data with allied forces and enhancing the effectiveness of the entire network. It is important to recognize that the comparison between the F-22 and the F-35 is not a matter of superiority in absolute terms, but of specialization and strategic context. The F-22 excels in achieving and maintaining air dominance in contested environments, while the F-35 provides unparalleled versatility and interoperability. Together, they represent a complementary approach to modern warfare, where success depends not on a single platform, but on the integration of multiple systems working in concert. Beyond these aircraft, the United States continues to push the boundaries of what is possible in military aviation. One of the most significant developments currently underway is the Next Generation Air Dominance Initiative, often referred to as NGAD. Unlike previous programs which focused on individual aircraft, NGAD is conceived as a system of systems encompassing not only a next-generation manned fighter, but also a range of unmanned platforms, sensors, and support technologies. This approach reflects a broader shift toward distributed and collaborative forms of combat, where multiple assets operate together to achieve a common objective. Central to this vision is the concept of loyal wingman drones, autonomous or semi-autonomous aircraft that accompany manned fighters performing tasks such as reconnaissance, electronic warfare, or even direct engagement with enemy targets. By offloading certain functions to unmanned systems, human pilots can focus on strategic decision-making, while the overall force becomes more resilient and adaptable. This integration of artificial intelligence and automation represents the next frontier in air warfare, one that could redefine the relationship between humans and machines in combat environments. At the same time, advancements in hypersonic technology, directed energy weapons, and cyber capabilities are poised to further expand the scope of aerial warfare. Future aircraft may operate at speeds and altitudes that challenge existing defense systems, while new forms of weaponry could enable precise, rapid, and scalable responses to emerging threats. These developments underscore a critical point. The evolution of military aviation is far from complete. It is an ongoing process shaped by technological innovation, geopolitical dynamics, and the ever-changing nature of conflict. In assessing which American aircraft stands at the pinnacle of global capability today, one must consider both technical performance and operational context. From a purely air-to-air combat perspective, the F-22 Raptor remains the most formidable platform, combining stealth speed and maneuverability in a way that few, if any, aircraft can match. However, in terms of overall versatility and integration within modern Razmakan networks, the F-35 Lightning II arguably represents the more influential system, particularly given its widespread adoption among allied nations. Ultimately, the question of the best aircraft is less about a single answer and more about understanding how different platforms contribute to a broader strategia. Air dominance in the 21st century is not achieved through isolated superiority, but through the seamless integration of capabilities across multiple domains. The United States has maintained its leadership in this majal, not only by developing advanced aircraft, but by continuously adapting its doctrine, investing in research, and fostering collaboration among its allies. As we reflect on this century-long journey from the fragile biplanes of World War I to the stealth-enabled data-driven systems of today, it becomes clear that American military aviation is defined by its capacity for reinvention. Each generation has built upon the successes and lessons of the past, pushing the boundaries of what is possible and redefining the nature of aerial warfare. And as new technologies emerge, this process of evolution will undoubtedly continue shaping the future of conflict in ways we are only beginning to understand. If you found this exploration insightful and would like to see more in-depth analyses of military technology strategy and global defense trends, consider supporting the channel. Share this video with others who are interested in understanding the forces that shape our world. Leave a comment with your thoughts or questions, and subscribe to Strategy Scope to stay informed on the next generation of ideas and innovations.